Hey everybody, you probably don't spend a long time thinking about how much oxygen you're using up as you go through the day, nor do you think about the fact that you are actually a combustion reaction. You carry out cell respiration. So, cell respiration is this equation. Glucose and oxygen combine to make carbon dioxide and water. You ever notice that you breathe out water? Your breath has moisture in it. So, astronauts find this considerably more important. So let's take a look at how much of their oxygen an astronauts would use up burning up the energy they get from 90 M&Ms. That's 180 grams of glucose. Now, first thing you have to look at is how many moles of glucose is that? Because remember, moles help us to talk about the number of particles and not just their mass. It's actually pretty big molar mass, 180.18 grams. That is a pretty big molecule, but finding it is the same as we've always done with molar mass. Once we're there, we need to figure out how many moles of glucose they ate. So notice that the 180.18 is on the bottom. That's so that this gram and this gram will cancel. That leaves you, if you cancel those out, with moles. 0.9990 moles of glucose. Now, once you have that many moles of glucose, you're ready to switch it to a different chemical. Again, we care about how many grams of O2 we're going to have to use to burn it. So let's start with the 0.9990 moles of glucose that we had at the end of the last step. We know that moles of glucose has to go on the bottom, and we know that moles of oxygen has to go on the top. This is a mole ratio. This is the last thing we learned. Now, in that balanced equation, there's a 1 in front of glucose. So I'm going to put a 1 here. And there's a 6 in front of oxygen. So I've got a moles of glucose canceling. So I'm going to multiply 0.9990 times 6. When I do that, I'm going to get 5.994 moles of O2. Okay, so I know how many moles of O2 that is, but that doesn't really give us a real knowledge of how much that is. So we need to convert that back to grams. So we start with 5.994 moles of O2, and we need to convert that to grams. Well, you've done these problems before. This is a molar mass problem. So moles of O2 goes on the bottom, and since we're using the molar mass, that's always 1. And then the mass of 1 mole of O2 goes on the top. And since it's O2, it's twice what's on the periodic table, 32 grams of O2. Moles cancels out, and you get 191.8 grams of O2, which is actually quite a bit of oxygen. So that's about the weight of like a can of pop of oxygen gas. So that takes up a lot of space. So it's important that astronauts keep getting more and more oxygen as they're in space because they're always using it up, turning into carbon dioxide and water. The good news is that the spaceship can actually recycle it using electricity. It breaks the water into H2 and O2. H2 is fuel. O2 is oxygen to breathe. So it works out nicely that way. The skill builder you're about to do walks you through each of these steps separately. So you'll be typing in your answer for each one, and that way you can get constant feedback. There's 2 of these problems for you to work through. Thank you. Talk to you later. Bye.